So today we want to talk about organic chemistry. Organic chemistry is one of the major branches of chemistry that deals with carbon-containing compounds. And these compounds are referred to as organic compounds. Organic compounds includes all carbon compounds except carbon 2 oxide, carbon 4 oxide, carbonate, bicarbonate, carbides, cyanides, and thiocyanides. So organic compound exists in a family called homologous series. So before we take the definition of homologous series, there are things we should know about this series. For example, let us take a look at alkanes, alkene, alkynes, alkanol, and they have this general molecular formula. For alkene is CnH2n plus 2. For alkene is CnH2n. For alkynes is CnH2n minus 2. For alkanol is CnH2n plus 1 OH. So here our n is greater than or equals to 1. Here our n is greater than or equals to 2. Here n is greater than or equals to 2. Here n is greater than or equals to 1. So let us see, if you put n equals to 1 here, we are going to have C, 2 multiplied by 1, that is 2, plus 2, that is 4, that is CH4. The next member we have n equals to 2, this is for n equals to 1, n equals to 2, we have C2, H6, n equals to 3, we have C3, H8, n equals to 4, we have C4, H10. For this, n equals to 2, we have C2, H4, n equals to 3, we have C3, H6, n equals to 4, we have C4, H8, n equals to 5, we have C5, H10. Then n equals to, for alkynes, n equals to 2, we have C2, H2, C3, H4, C4, H6, and C5, H8. Then for alkanol, n equals to 1, we have CH3, OH, n equals to 2, we have C2, H5, OH, n equals to 3, we have C3, H7, OH, and n equals to 4, we have C4, H9, OH. Now, when you take a look at each successive member of this series, you see that the difference between the first member and the second one is CH2. The difference here is CH2. The difference here is CH2. When you take a look at each of the successive members, you see CH2, 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 this unit, this particular unit, CH2. Each successive member differ by that what? By that particular unit, CH2. CH2. And when you look at it, you see that this family, they follow a regular pattern. They follow a regular pattern. They follow a regular pattern. So, by so doing, we can say homologous series, they are families of organic compounds that follows a regular pattern and having the same functional group and similar chemical properties, in which each successive members differs by the unit CH2 or factor 14. When you look at all members in alkene, they will possess this carbon-to-carbon single bond. When you look at all members in alkene, they will possess carbon-to-carbon double bond. When you look at all members in alkyne, they will possess carbon-to-carbon triple bond. While all members in alkanol, we have that functional group OH, the hydroxyl functional group. Now, from what we have here, we can easily state the characteristics of homologous series. The very first one that we can see is each successive member differs to the next by the molecular formula CH2, or you say unit 14, or you say factor, you say unit CH2, or molecular formula CH2, or the factor 14. All members in the same homologous series, they have the same general molecular formula. For alkanes, their general molecular formula is CN H2N plus 2. For alkene, their general molecular formula is CN H2N. For alkynes, their general molecular formula is CN H2N minus 2. While for alkanol, their general molecular formula is CN H2N plus 1 OH. That is the number 2 characteristics. Then the number 3 is that all members in the same homologous series have the same functional group. For alkanes, all of them, they possess this carbon-to-carbon single bond. For alkene, they possess this carbon-to-carbon double bond. Then for alkynes, they possess this carbon-to-carbon triple bond. For alkanol, they possess this hydroxyl functional group. And since all members in the same homologous series have the same functional group, then their chemical properties will be similar, because it's the functional groups that determines the chemical properties of an organic compound. So we say that all members in the same homologous series have similar chemical properties. So another class on organic chemistry. In our previous class, we realized that these organic compounds, some of them have carbon and nitrogen, some have carbon and other elements like oxygen, nitrogen, fluorine, chlorine, sulfur, etc. So that now takes us to how can we classify these compounds. So the International Union of Pure and Applied Chemistry now came together to now classify them into 2 aspects. Basically, they have classified them into 2 types: hydrocarbons and functional group. Hydrocarbons and number 2, functional groups. Now, but let us start with these hydrocarbons. What are hydrocarbons? As the name implies, hydrocarbons are the organic compounds that contains carbon and hydrogen only. So these are the organic compounds that contains carbon and hydrogen only, like CH, hydrocarbons. So hydrocarbons can be classified into 3 parts. The first one, aliphatic hydrocarbon, cyclic hydrocarbon, then and aromatic and non-aromatic hydrocarbons. This your aliphatic hydrocarbon can also be known as acyclic hydrocarbons. Acyclic hydrocarbons, or you call it aliphatic hydrocarbon. Now, let us talk about the aliphatic hydrocarbons. Aliphatic hydrocarbons, they are referred to as the open chains hydrocarbons. That is, there is no bond that is linking the first carbon atom and the last carbon atom in this form. So this is what we call what? Aliphatic hydrocarbon, and it can be divided into 2. You have the straight chain and the what? And the branch chain. The straight chain and the branched chain. So if you see a compound in this form, like when their chain is open, they are referred to as what? Aliphatic. Or you see a straight chain that is open and you have another carbon that is branched in this form, they are referred to as what? The branched chain. So we have a straight chain and branched chain. Then cyclic hydrocarbons. Cyclic hydrocarbons, they are the closed chain hydrocarbons. That is, there is a bond linking the first and the last carbon atom. In fact, it's very difficult to identify the first and the last carbon atom when you are talking about types of hydrocarbons. Types of hydrocarbons. Basically, we have two types of hydrocarbon. The first one, saturated hydrocarbons. Saturated hydrocarbons. Then the second one is what? Unsaturated hydrocarbons. Saturated hydrocarbons and unsaturated hydrocarbons. Now let us pick the saturated hydrocarbons. Saturated hydrocarbons. Now, what are saturated hydrocarbons? Saturated hydrocarbons are the hydrocarbons that contains carbon to carbon or carbon to hydrogen single bond. They contain carbon to carbon or carbon to hydrogen single bond. So from our previous class, you realize the point where we wrote alkane, and we said they have this general molecular formula CnH2n+2, and we say they contain carbon to carbon single bond. So when you are talking about saturated hydrocarbon, basically we are talking about the what? The alkanes. They are also known as the alkanes, and they are represented by the general molecular formula CnH2n+2, where our n is greater than or equals to 1. So the simplest molecule of alkane homologous series is methane. With molecular formula CH4. That is the first member of that group, CH4, and the structure is like this. That is one of the unique properties of carbon, tetravalency. They are linked to 4 bonds. They have 4 bond tetravalency. You can see that. So this is tetravalency. To one carbon atom, there is always what? 4 bonds. So this is the structure of methane. Then I will show you a table now that shows other members of the group, their molecular formula and their IUPAC name. Let us say here is N. This is their molecular formula. Which is CnH2n+2, and their IUPAC name. So if n equal to 1, we have CH4, and that is what? Methane. If n equals to 2, we have C2H6, and that is what? Ethane. If n equal to 2, we have C3H8, and that is what? Propane. If n equal to 4, we have C4Hn, and that is butane. If n equal to 5, we have C5H12, and that is pentane.